Okay, you can see now, right?
Yes, sir.
So let's see. Enable is the command and show run interface serial 1/0. In 1/0, we have this 102 mapped with serial 1/1 201, right? 102 mapped with 201. So 102 is coming from 1/0. So we entered into the serial 1/0 and given these commands. So under 1/0 frame relay route 102 with 201. So interface serial number 1/1 201. The same way 103 is coming here and it is going to 1/2 with 301 DLCA. 103 with serial number 1/2 301. The same way serial 1/1. So 1/1 is again 201 with 102, and one more thing here 1/2 with 301 and 103. So let's see, do we have any Eigrp configuration? So Eigrp configuration is already there. 1 minute, let me, this is for the another class. So just load the router. Okay, now you see here, so in our last class only we have seen 102 DLCA mapping, only 102 with 201 and 103 with 301, right? So if you go here and try to ping 10.1.1.2, you can able to ping it. 3 also you can able to ping it. From here just ping 10.1.1.1, you can able to ping it, and from 3 you cannot able to ping it, right? So you mean to say that from here to here you can able to ping it, and here to here also you can able to ping it, but you cannot able to ping here and here to here, right? 104 DLCA to 1401 DLCA you cannot able to ping it. And one more thing here in R3 ping 10.1.1.1 you can able to ping it. 1.1.1.2 you cannot able to ping it. So here very simple, right? Only these two are not pinging. So just you need to route here and here, correct or not? You have to map this DLCA, right? 104, correct or not? So go here and just to show IP interface brief. Serial 1/0 is going to R1, serial 1/0 is going to R1, 1/1 is going to R2, 1/3 1/2 is going to R3. Okay, now go to again here, just show run serial 1/0. 1/0. So this mapping is there, 102 201 103 301. This is fine. 1/1 102 201 102 is also there, but now the mapping is required between 401 and 104 and 401. Okay, that means the traffic coming from here to here with go as DLCA as 104, and it will this packet will go as DLCA 401, right? So conft interface serial 1/1 frame relay route. What is the DLCA value of there? 104. Interface serial. What is the interface? Outgoing interface. What is that? 1/2. What is the DLCA value? 401. What is the DLCA value? 401. Just we didn't do anything here. Just here on this serial interface, the packet which is coming from this interface going towards this R3 will map as 104 and 401. The same way you have to do for serial 1/2 also. What is that? Frame relay route 401 interface serial 1/1 104. That's it. So just put show frame relay map. Show frame relay root. Show Framerelay root. All are active. 102, 301, 104 DLCI is also active. So once you've done that, go to R2 and try to ping 103. 10.1.1.3. It is pinging. Here also, just go to here and try to ping 10.1.1.2. It is also pinging. Are you guys clear till here?
Yes, sir.
Now so the connectivity is there between everyone, right? Between 10 dot, so this is 10.1.1.1, 1.2, 1.3. You can able to ping each other, okay, through Framerelay. So we made Cisco router as Framerelay router, and you can able to do it. But and you have loopbacks 1.1.1.1/32, 2.2.2.2, 3.3.3.3. Go here and check for show IP interface brief. We have already created a loopback. In R1, and go to R2, and here also loopback 0, 2.2.2.2, and here also show run interface loopback 0, 3.3.3.3. Just I am looking here whether is there any static routes here. I don't have any static routes. Just look at, so if you see the last video, I have used static routing, right? So now I am going to use EIGRP router, EIGRP 100, no auto summary, network 0.0.0.0. Clear? These are the commands we have to use, right? Correct or not?
Yes, sir.
Router EIGRP 100, network 0.0.0.0. The same commands here also. Conf router EIGRP 100, network 0.0.0.0. So once we done that, you see here neighborship has been formed. Show IP EIGRP neighbor. So R3 is having two neighbors, 10.1.1.2 and 10.1.1.1. And here also for this guy also you have EIGRP neighbors. So for R1 also, so R1 has two neighbors, R2 and R3. R2 has two neighbors, R1 and R3, and R3 has two neighbors, R1 and R2. So go here and again check for show IP EIGRP neighbors. There are two neighbors for R1, R2 and R3, right? Now check the routing table now. Show IP route EIGRP. You see here, so okay, so now we have broken the DC link between 104 to 401 DLCI. So this communication will not work, but this only the point to point connectivity will get established from here to here. Okay, so this is now dot 1 can able to ping dot 2 and dot 3, and dot 3 can able to ping dot 1, and dot 2 can able to ping dot 1, but these two cannot able to ping each other. So if you see here, for in R1 you can see two neighbors, but in R2 show IP EIGRP neighbor, you can see two neighbors, 10.1.1.1 and 10.1.1.3. Still you can able to see two neighbors, and here also you can, so 10.1.1.1 and 10.1.1.2 you can able to see the neighborship. But the thing is, if you see the routing table here, show IP route EIGRP, still you can see 3.3. Okay, R you can able to see R2 loopback and 3 loopback. If you see here, show IP route EIGRP, you can see 1 loopback and 3 loopback. If you see now, show IP EIGRP neighbors, you can see 1 and 3. And here in R2, if you see here, show IP EIGRP neighbors, you will see only one neighbor, right? 10.1.1.1. and here also you can see show IP EIGRP neighbors. So you can able to see only one neighbor. Why? Because here from here to here we can able to ping, here to here we can able to ping. So when you configure EIGRP here, only R1 can see two neighbors and R3 can see only one neighbor. R2 also can see only one neighbor, which is right. So if you see here show IP root EIGRP, I can see 2 and 3. I can see 2 and 3. What I mean to say is, so here when I see, I can able to get the routes of 2.2.2 and 3.3.3.3. And if you see the routing table of 2, show IP root EIGRP, I can see only 1.1.1.1. If you see the route here, I can able to see only 1.1.1. Only this it is giving to this guy. So for suppose on R3, if I go show IP root EIGRP, I can only see again only one, which is R1. Only this loopback it is giving to this guy. But whereas this R1 will have 2 and 3 also, right? Which is learning via EIGRP. But this guy, see, R2 is giving 3 to here, and R2 is giving to loop back to here. But this guy is not giving these two here. Okay, either here or here. You know why? Actually we have one looping algorithm, which is split horizon rule. Split horizon rule will be enabled on each and every interface, EIGRP interfaces. So you have to disable that split horizon rule. So whatever the updates we are getting here, so it will give it to the neighbors. For suppose first it will get the update from here, from this link. So this router will not give any EIGRP updates to this router. So it can only take, but it won't give anything. So if you want to do that, so you have a command called interface is serial 1/0 1/0 no IP split horizon EIGRP 100. This is the command you have to give. This is the command you have to give. Where and all you have to give? You have to give here, you have to give here, you have to give here, and go to here and interface serial 1/1, and here conf t interface serial 1/2, and apply the same command. Once you give this one here, show IP route, show IP route EIGRP. You see here now 1.1 and 2.2 you can see, and the same way you check the routing table here, you see 1.1 and 3.1, so that you can able to ping from here, ping 2.2.2.2. You can able to ping it, ping 3.3.3.3. Clear? Now let's do route filtering or neighbor filtering. Okay, so let's do something here. Here we will put some few networks here. Okay, just we will put 20.1.1.0/24, 20.1.2.0/24, 20.1.3.0/24 here. Okay, these are the networks is here, and first let's see filter 10.0.20.1.1.0. We will filter from here. Okay, first we will create these. First we will create these networks on R1. Go to R1, exit, let's create networks here. Just first see show IP interface brief. Let's create 20.1.1.0 conf t interface ethernet 0/0 IP address 20.1.1.0 255.255.255.0 dot one no shit, and ethernet 0/1 20.1.2.1 no shit, 3.1 no shit. Show IP interface brief. So you see here 20.1.1.0, 20.1.2.1 network and 3.1 network. If you go here and check the routing table, show IP route Eigrp, you see here 20.1.1.0 network, 20.1.2.0 network and 3.0 network you can get from R1, okay, via Eigrp. So go here and check the routing table. You can see 20.1.1.0 and 20.1.2.0 and 3.0. So from this router, this is Hyderabad, Bangalore and Kolkata, right? So I want, here I want to see only 20.1.1.0. I want to see here, and I want to see only 20.1. No, I want to see 2.0 and 3.0 here, and I want to see 1.0 and 3.0 here. Okay, so now go to R2. So how many types of route filtering we have? 3 types. One is access list. You can create access list, you can create distribute prefix list, and you can create route map. Okay, these are the 3 types. So first let's see what is an ACL. Before getting into route filtering, first we will see what is an access list. Access list is a set of rules which allows or denies the specific traffic moving through the router. So for suppose I have 192.168 some IP subnet here. So here 192.168.2.0 subnet here. Here 192.168.3.0 subnet here. Okay. So I want 1.0 should only communicate with 2.0 but not 3.0. Okay. That means we have to filter the traffic. For suppose 192 only restrict with here. So I have to put one one security guard here and just make all the necessary things. I mean to say that I want this communication should happen, but I don't want this communication. Okay, so what I need to do is I have to prepare some ACLs. So you need to filter the rules. You can create certain rules saying that 192.168.1.0 should only communicate with 2.0, but it should not communicate with 3.0. So these are the rules we have to write. These are the rules you have to write. These rules are nothing but packet filtering. These rules are nothing but packet filtering firewall. So nothing actually. What it will do first, what router will do first, it will check the source IP and destination IP. So when it checks source IP and destination IP, source will be 1.0 and 2.0. It will allow the packet. For suppose if you put the ACL here, and it should be outside. If it is going inside the router, it is inside. Okay, for suppose you have 1.0, and always you will put near to the destination. ACLs you always put near to the destination. Why? Because if you put it here, you have to do it for suppose if there are 100 routers here, I mean 100 networks here, you have to do the ACLs for all these 100 networks. So always you have to do it near to the destination. So for suppose 1.0, so you have to write one ACL here on this router. So if this guy 1.0 would coming for 3.0 here, if you apply the ACL here, so when it go in, then it will stop it here only. And if it goes for any other network other than other than 3.0, if it comes for any other 4.5 network, it will allow the traffic. Otherwise it will, if it is going for 1.0 to 3.0, it will deny the traffic. It will deny the traffic. So ACL is a set of rules which allows or deny the specific traffic moving through the router, and it is a layer 3 security which controls the flow of traffic from one router to another router. So how many types of ACLs we have? One is numbered ACL and we have named ACL. In the numbered ACL, you have again standard ACL and extended ACL, and you have named ACL also. You have standard ACL and extended ACL. Standard access list name range is 1 to 99, and the access list range is extended ACL range is from 100 to 199. You can block only a network host and a subnet, but here you can allow the source and destination as well. Deny a network source, subnet, and service also you can able to allow here. And all services are blocked here if you block any destination, but selected services can be blocked here. Implemented closest to the destination, if it is a standard ACL, it should implement it closest to the destination. If it is extended ACL, it will implement it closest to the source. Filtering is done based only on source based, and filter is done based on source IP, destination IP, port protocol number, and port number. What it mean to say is, for suppose router 1 here and router 2 here, and you have one subnet 1.0, and you have two subnets here 2.0 and 3.0, then what happens, if this guy 1.0 would like to you know if 1.0 would like to access 2.0, then if you want to use standard ACL, always you have to uh, you know implement this closest to the destination. Why? Because this is standard ACL. So here you have to put it. So 1.0 should not talk with 2.0, and I am using standard ACL. So here I will write 1.0 should not communicate with 2.0. So if I do it here, so this is out. So instead of this, the traffic already reaches the 1.0, it is already getting inside the router. So what I'll do is I'll filter it here only. So 1.0 should not communicate with 2.0, and 1.0 can communicate with hello, can you hear me?
Sir, yes, sir, but your screen is blank.
Yes, sir, but your screen is not audible.
Yeah,
Okay.
yeah. Sorry.
Okay. So 1.0 can able to communicate with 3.0. That means traffic it will block, and this traffic it will allow. So this traffic is coming inside the router, so it is blocked here, right? It is going in, and from this interface it is going out. Okay. If you want to put it here, it will be out, and if you want to put it here, it will be in. You understand this in and out concept? You understand in and out or not?
Yes.